It's an exclusive. We have a really big community here, and really smart. And I can learn a lot of good stuff from our community. So if you are a space nerd that likes to talk about space, consider becoming a Patreon member at patreon.com/everydayastronaut, and there you can gain access to our Discord channel. And I think I might be able to link that up through YouTube membership too. If so, I'll let you know. But in the meantime, they have a really good discussion about why thinking that all launches to the International Space Station had to be instantaneous. This is not true. As a matter of fact, the Atlas rocket took this same Cygnus capsule on top of it for OA6 and OA something else that kind of went out of order. It was really weird. And Atlas had a 40-minute window for the International Space Station. How can you do that? How can you do that? So it all comes down to the rendezvous. They do have to match up with the orbit. The orbit of, let's pretend that this is the orbit you're trying to line up, and the Earth is spinning underneath you. You do have to take off within a certain amount of time in order to line up on that same orbital inclination. Otherwise, you'll miss your orbit. You'll end up a few degrees off, or you'll end up a few planes off, and that's really hard to get back and get lined up and actually rendezvous at that point. So you do need it to be really close, but there are dogleg maneuvers that vehicles can do. And this vehicle has a 5-minute window, so they have to program basically every second. The exact second that the vehicle takes off, it needs to know how much of a dogleg it needs to do so that it can line up on the inclination and correct for it in a mid-course burn. And that must be something they almost have to do that with the insertion of the upper stage, I would guess. Because the upper stage, once it turns on, it basically just goes. They can't throttle. They can change degree, but they basically probably point and go boop, and that'll line them up perfectly on their inclination. The Falcon 9 has an instantaneous launch window for a few reasons. Even before super chilled propellants, it's never had the ability to dogleg. They don't program that in, even though it is capable of doing so. But the big thing is now they do have super chilled propellants. They require the prop and the liquid oxygen to be absolutely as cold as possible. They don't want it to warm up even all the way, warming all the way up to the what's it called? Vapor point? What's that called? Not melting point. Melting. There's melting and freezing, but then after that, gas point. What's that called? But yeah, SpaceX actually chills it down almost to the liquid oxygen being a solid, and they chill the RP1 down to where it starts to get almost sludgy. Like it doesn't all freeze up right away like into a solid. It kind of gets sludgy first. And they chill their fuel, the RP1, up like that. So they don't allow for anything other than the instantaneous launch window with the Falcon 9. This vehicle, of course, it uses liquid oxygen, but they are okay with it venting and purging and boiling off, and they just keep topping it back off. And as a matter of fact, this vehicle loads up on LOX like an hour and a half ahead of time, and they just keep it topped off the whole time it's sitting on the pad. No big deal. But yeah, the dogleg is the reason why they can do certain orbital inclinations and match up even on in a rendezvous with the International Space Station. And if you don't care about having the coldest liquid oxygen that you can for the performance of your vehicle, then it doesn't really matter. Said too much. Evaporation point. Flash point, boiling point, flash point, boiling point, boiling point, boiling point. Just boiling point. Just boiling point. That's good enough. The ouch, it hurts point, says Tim Botran. Yeah, sweet. There we go. We have a few more things here before I'm probably going to turn this back up here soon and listen in now that we're getting pretty darn close. I don't like when they take the clock away. In about 1 minute, we'll listen to the final count. Actually, I'm going to listen in now.
Three minutes before launch, we're now in the terminal count until launch on time, 3:46 p.m. Central Time.
Nice, on-time launch. I like that.
Podium bus voltages and currents are nominal.
No, this is not in Florida. This launch is at Wallops,
verify ready for
Virginia.
nav mode.
LC nav, orb nav ready for nav mode.
Ops 2, step 421, switch to nav.
Orb nav to navigate. LC nav, orb nav telemetry verified.
And guys, I'll get to the rest of your
check
few chats
422
here
complete.
after launch. I think we better listen in here, though. Sounds like everything's good to go, though.
And T-minus 2 minutes on my mark. Mark.
Okay, so my clock's about 25 seconds ahead, so keep that in mind. I'll turn it off here at about T-minus 1 minute, just so we don't get super confused.
Now under 2 minutes for launch, everything's still looking good during this automatic countdown.
It's a good question.
T-minus 1 minute, 30 seconds on my mark.
Okay.
Mark.
So 1:30 here. Yes. We're going to see a rocket launch today. Can't wait. I feel like it's been a while.
T-minus 1 minute on my mark.
Here we go, guys.
Mark.
Mark. 1 minute, guys.
Now under a minute to launch, in just about 10 seconds, the intakes will be pressurized. Everything's still on track for liftoff on time.
Someone asked, will the stream cut out right at T0? I'm trying so hard. I'm going to have a better solution for the next launch. I'm tweaking it. I like covering the launches live, though, in person, because it's awesome to see a rocket launch.
T-minus 30 seconds.
I almost think this is easier, but of course this is way easier. I think you guys honestly like it just as much, but... Okay. Oh, I also should confirm real quick, guys. It does appear the pointy end is up, and the flamey end is down. I think we're good to go. We have
T-minus
about...
10.
Here we go.
5, 4, 3, 2, 1.
Ignition.
And we have
There we
engine
go.
ignition.
Yeah, baby.
And we have liftoff of the Antares NG-11 mission to the ISS. Engines at full power.
Yes.
Attitude is nominal. Core
Look at that,
pressurization looks good. Power systems look good.
Right on time.
Stable operation, full power, both engines.
Wow.
Core pressures look solid. Attitude is nominal. TVC is nominal.
Dang.
Power systems look good. Engines remain at full thrust, operating nominally.
Everything looking good during this first stage burn. It burns
Altitude
for 3 minutes, 35
feet,
seconds.
Throttling back to 55% power. Attitude remains nominal.
It's a deep throttle for their max Q.
Nominal operation at 55% power.
Whoa.
Throttling back up to full power. Engines
Wow.
are back to full power.
Wow.
TVC remains nominal.
That happens so fast. Throttle down and
Nominal
throttle up.
T plus 60 seconds.
It hit max Q that quick?
Altitude passes 25,000 feet.
It's about 12
Pass through transonic.
8,000 kilometers, or 8 kilometers, sorry.
Attitude is nominal. Engines continue to operate at full power.
Everything looking good. About 10 more seconds of this first stage burn.
Nominal attitude.
That's it?
40,000 feet altitude. Engines remain nominal, full power.
This is a crazy different flight
Fuel
profile.
pressurization is nominal. VNG3 is on. Altitude past 60,000 feet.
50,000 feet.
Engines remain nominal. Attitude and power systems all look good.
Coming up on about 20 kilometers.
Coming up on T plus 2 minutes.
Still burning.
Engines continue to operate nominally at 100% power. TVC steering, power systems,
2
attitude
minutes
all
into the
look good.
flight, 1 minute 30 seconds until this main engine cut off.
Okay, so the first stage is going to burn for 3 minutes and 30 seconds, so quite a bit
Power
less
systems
than
remain nominal.
like a Atlas V, but quite a bit
Attitude is
more
good.
than a Falcon 9.
Engines continue to operate at full power. Engines remain nominal. Power systems are good.
Nice.
Attitude is nominal.
And don't forget, guys, the RD-181 they're using is a
Core
closed
pressures
cycle
look
engine.
nominal. Approximately 1 minute till main engine cutoff.
And I'm doing a video right now about that and about the Raptor
Engine
engine.
power is nominal.
So I'll probably be referencing the RD-180, which is a sibling to this
Attitude
engine.
is nominal.
Avionics power is good. We're starting our slow throttle ramp for G limiting. 200,000 feet altitude as we approach T plus 3 minutes. Attitude remains nominal. 10,000 feet per second. Engines are throttled back to 55.
About 30 more seconds of this burn. Main engine will cut off, stage 1 will separate, and the vehicle will coast for just a bit before fairing separation.
Engine operation at 55% power is nominal. TVC slew for main engine cutoff is started. Attitude remains nominal. Engine operation continues to be nominal.
1,200 millimeters.
Altitude 300,000 feet. And we have main engine cutoff.
Looking good. They do call out.
Attitude remains nominal post shutdown. Stage 1 separation. ACS performance is nominal. Stage 2 ignition will be in approximately 30 seconds.
Again, this is a coast period.
Antares is now coasting in preparation for stage 2 ignition. Stage 1 delta V was 17,348 feet per second. Altitude is 130 kilometers. Interstage SEP. Attitude remains nominal. Attitude remains nominal. The Castor 30XL motor will burn for approximately 2.5 minutes. Attitude is nominal. Motor pressure is nominal at approximately 100 psi. Power systems look good. Stage 2 TVC is nominal. And attitude remains nominal. TVC is nominal.
Not even mad. TVC
Power is good. Motor pressure is now approximately 685 psi.
685 psi.
Velocity 6 kilometers per second. 200 kilometers.
Here we go.
Stage 2 TVC looks good.
I like this shot.
Power is nominal.
Okay.
Motor pressure just entering its slow tail off, now dropping below 500 psi.
It's about 2/3 of the way. Huh.
TVC remains nominal.
Just so you guys know, I'm going to,
Power is good.
since this is updating every 5 seconds, I'm going to turn them down for just a second. So at this point in real life, this animation is wrong. The first stage is gone. The fairing is gone, and they're just burning this solid rocket motor at this point. Stage 2 motor burnout. Really? Anyone else? Huh. So the Cygnus must have to make up another about 500. They must have to circularize itself. About 500 miles an hour, so 800 kilometers an hour.
Loss of signal on motor cone and stage 1. All systems look good. We're just standing by for Cygnus spacecraft separation. Attitude remains nominal. And all systems look green at this point. Avionics, power systems, attitude all look nominal as we come up on mission time T plus 490 seconds. Vehicle is now oriented for spacecraft separation. Attitude is nominal.
Yeah, Gary, it looks like our telemetry is a little unusual here. I think we're showing a bit of a stale vehicle graphic here. At this point, we've got the stage 2, the Castor 30XL, with the Cygnus payload still attached, coasting and ready for deployment. So imagine that instead of what we're showing here.
That's what I thought.
Attitude is good. Power systems look good.
Sounds good, and just about 9 minutes after liftoff, we should be expecting Cygnus separation.
All systems nominal at this point. Attitude and power continue to look good. And we have Cygnus spacecraft separation.
Yay.
Aries is reorienting for the collision and contamination avoidance maneuver. Insertion orbit looks nominal.
Everything looks good.